Welcome to Module 1, Introduction to Artificial Intelligence. In this module, we'll explore 4 key areas. First, an overview of artificial intelligence, where we'll discuss what AI is, types of AI, how AI works, and the evolution of AI. Second, we'll move to an introduction to machine learning, covering what machine learning is, types of ML, and common ML algorithms. Third, we'll examine key artificial intelligence technologies such as natural language processing, computer vision, deep learning, and generative AI. Finally, we'll look toward the future of artificial intelligence and the advancement of AI. This module will set a strong foundation for understanding artificial intelligence and its core principles. As we progress, this foundational knowledge will support your learning in the upcoming modules, where we'll dive deeper into practical AI applications, explore specific use cases in law, and discuss how AI can enhance legal practice. With this understanding, you'll be well equipped to grasp more advanced AI concepts and tools relevant to the legal field. Artificial intelligence, or AI, is the science of building systems that perform tasks typically requiring human intelligence. A key feature of AI is its ability to learn from data, identifying patterns, and improving performance over time, much like humans. AI excels at solving complex problems by analyzing vast datasets, uncovering insights, and offering solutions that would be difficult for humans to handle manually. At its core, AI mirrors human behavior, learning, decision-making, problem-solving, and understanding language, while enhancing our ability to tackle challenges in unprecedented ways. AI can be divided into 2 types: narrow AI and general AI. Narrow AI focuses on specific tasks. For example, apps like Google Translate can accurately translate languages, but they can't perform tasks outside their programming. General AI, on the other hand, aims to mimic human intelligence across all domains. While we're not there yet, significant advancements are happening. Technologies like advanced robotics and neural networks are bringing us closer to achieving truly adaptable and human-like AI systems in the future. Let's understand how AI works. It begins with data collection and preparation, where raw data is gathered, cleaned, and enhanced for quality to create a strong foundation. Next, we have algorithm selection. The choice depends on the problem. Supervised learning for labeled data, unsupervised learning for discovering patterns, and reinforcement learning for decision-making. During model training, the AI learns by adjusting parameters to minimize errors and improve accuracy. Then, the model undergoes evaluation to ensure it performs reliably in real-world scenarios. Afterward, it's deployed into systems for practical use, helping solve specific tasks. Finally, with continuous learning, the AI evolves by adapting to new data, staying accurate and effective over time. This process is what drives AI's intelligent performance. Artificial intelligence, a term that once belonged to the realm of science fiction, is now an integral part of our daily lives. But how did we get here? Let's take a journey through the milestones that shaped the evolution of AI, transforming it from an ambitious idea into a groundbreaking reality. The dawn of AI. It all began in 1950 when the visionary Alan Turing posed a bold question: can machines think? Turing proposed the famous Turing test, suggesting that if a machine could convincingly mimic human conversation, it could be considered intelligent. Fast forward to 1956, the birth of a term. When John McCarthy introduced the term artificial intelligence at a workshop in Dartmouth. This marked the official birth of AI as a field of study, inspiring researchers worldwide. In 1964, AI took its first steps in human interaction with Eliza. Created by Joseph Weizenbaum, this chatbot could simulate conversations, paving the way for the virtual assistants we know today. Then came a game-changing moment in 1997. Deep Blue, IBM's chess-playing computer, defeated world champion Garry Kasparov. This victory showcased the computational power of AI and marked a major leap in its development. A robot with personality in 1999, Sony brought AI into our homes with Aibo, artificial intelligence robot, and also means friend in Japanese, the robotic pet dog. Aibo wasn't just a toy, it learned and adapted over time, becoming a companion with a unique personality. By 2002, AI had entered our homes in another form, the Roomba. This robotic vacuum cleaner could navigate homes, marking a new era of practical AI applications. Then, in 2011, AI became personal. Apple introduced Siri, the intelligent pocket assistant that revolutionized how we interact with our devices, offering a glimpse of AI's potential in our everyday lives. In 2014, IBM's Watson stunned the world by winning Jeopardy, a quiz competition. Watson's ability to process complex questions and provide accurate answers highlighted the advancements in AI's language processing capabilities. By 2020, Amazon's Alexa had become a household name. This intelligent assistant not only answered questions, but also handled shopping tasks, showing AI's growing integration into consumer life. And finally, in 2022, we witnessed the launch of GPT-3 and its public-facing sibling, ChatGPT. These tools showcase the power of AI-driven conversations, setting new standards for creativity, problem-solving, and interaction. From its humble beginnings with the Turing test to the advanced conversational tools we use today, AI's journey has been nothing short of extraordinary. And as we continue to innovate, the possibilities are limitless. This is the evolution of AI, a story of ideas, innovation, and impact. Let's explore what's next in the world of AI together. Welcome to the world of machine learning, one of the most exciting fields in artificial intelligence. But what exactly is machine learning? Let's understand. Machine learning is a fascinating branch of artificial intelligence that allows computers to learn from data. Instead of being explicitly programmed for every task, these systems analyze data and improve their performance over time, just like we learn from experience. What makes it special? Machine learning algorithms are adaptive. They get better as they process more data. For example, the more you use apps like Netflix or Spotify, the smarter they become at recommending content you'll love. From recognizing faces in photos to predicting trends in business, machine learning powers many technologies we use daily. It's all about helping computers learn, adapt, and make our lives smarter and more efficient. Machine learning can be divided into three main types, each with a unique way of learning and solving problems. Supervised is like having a teacher. Unsupervised is like exploring without guidance. And reinforcement is like learning from mistakes. Each type of machine learning is tailored to a specific kind of problem solving. Let's make machine learning easy to understand by comparing it to how a baby learns from a teacher or their environment. Imagine a teacher showing flashcards to a baby. The teacher points to a picture of an apple and says, "This is an apple," and then shows a picture of a banana and says, "This is a banana." Over time, the baby learns to recognize apples and bananas based on these labeled examples. This is exactly how supervised learning works. An algorithm is trained with labeled data to make accurate predictions later. Now, imagine the baby is given a basket of fruits without any labels or guidance. The baby explores the fruits, touching, tasting, and observing them. Eventually, the baby groups the fruits based on similarities like color, size, or texture. The baby doesn't know their names yet, but discovers patterns. That's unsupervised learning, finding hidden structures and patterns in unlabeled data. Finally, picture the baby learning to walk. Every time they take a step, the parents cheer and clap, rewarding the baby. If the baby falls, there's no cheer, and they try again. Over time, the baby learns to take more steps and fall less, optimizing their behavior to receive more rewards. This is how reinforcement learning works, learning through trial, error, and feedback. Let's explore a few common machine learning algorithms. Decision tree. Let's understand using a simple example. The tree makes predictions based on questions like, is the person's age less than 15? And is the person male? For instance, a 12-year-old girl is predicted to like games. A 25-year-old man has a strong likelihood, and a 30-year-old woman has a slight chance. The tree gives us scores to show the likelihood, with higher scores meaning a stronger prediction. Next is neural networks. Think of neural networks like your brain learning to recognize a cat. When you see a cat, your brain notices features like pointy ears, whiskers, and a tail, connecting these to form a pattern. In a neural network, there are 3 layers. Input layer takes in raw data, like pixels of a cat photo. Hidden layer processes the data, combining features like ears, whiskers, and fur. Output layer makes the final decision, like saying, yes, this is a cat. Just like your brain, neural networks learn by connecting patterns in data to make decisions. Support vector machines, or SVMs, are a powerful tool in machine learning. They work by finding the best way to separate data into different groups. Let's understand with an example. Imagine you're hosting a party with 2 groups, teenagers and adults. SVMs work like drawing a line to keep these groups apart. First, SVM looks at your data and finds the best line, called a hyperplane, that separates the groups. Then, it maximizes the gap between them. The points closest to this line are called support vectors. SVMs aim to create the largest gap, ensuring the groups stay well separated. Till now, we've learned about machine learning. Now, let's dive into other AI technologies that are crucial across all industries, including law. Natural language processing, or NLP, uses machine learning to analyze text and uncover its structure and meaning. It helps computers understand human language, which is crucial for extracting valuable insights from large amounts of text. In the legal sector, NLP has several powerful applications. Document review. NLP can automatically analyze contracts or legal documents to extract key clauses, saving lawyers time. Legal research. It helps lawyers quickly find relevant case laws by analyzing text in casebooks, rulings, or legal articles. Predictive analytics. NLP can analyze previous court decisions to predict the likely outcome of a current case. Sentiment analysis. It helps analyze public opinion or social media discussions related to legal cases or topics. NLP is making legal work faster, smarter, and more efficient by transforming how we process and analyze text. Computer vision is a branch of AI that enables computers to see and understand visual data like images and videos. Just like humans recognize objects, CV helps computers detect, analyze, and interpret what's in a picture. For example, in law, computer vision can analyze video footage from a crime scene to identify key details, such as faces or objects. If a suspect is caught on camera, CV can help identify them, aiding criminal investigations. It can also scan legal documents, extracting key information like clauses or dates, making the process faster and more efficient. In simple terms, computer vision allows computers to see and understand images, revolutionizing how we use visual data in the legal field. Deep learning is an advanced AI technique that trains computers to process data in a way similar to how the human brain works. By recognizing complex patterns in images, text, audio, and other data, deep learning models can provide valuable insights and predictions. In the legal field, deep learning has several powerful applications. Document review. It automates the review of legal documents, identifying key clauses and flagging potential risks. Legal research. It helps lawyers quickly find relevant case laws and precedents based on specific legal terms or concepts. Contract analysis. Deep learning models analyze contracts to spot inconsistencies or missing clauses that may cause legal issues. Predictive analytics. By studying past case data, it can predict the likely outcomes of current legal cases. With deep learning, legal professionals can work smarter, save time, and make more informed decisions. Convolutional neural networks, CNNs, are a type of deep learning algorithm designed to recognize patterns in images, text, and audio. CNNs are highly effective for identifying objects, categories, and classes within visual data, but they can also be applied to other types of data like time series or audio signals. In the legal field, CNNs have several key applications. Document classification. CNNs can automatically sort and categorize legal documents, such as contracts or case files, making it easier to manage large data sets. Image and video analysis. They can analyze crime scene images or surveillance videos, helping identify important details or detect anomalies in investigations. Facial recognition. CNNs assist law enforcement in identifying suspects from video footage or photographs, enhancing criminal investigations. Signature verification. They can verify signatures on legal documents, helping detect forgeries or fraud. By automating these tasks, CNNs are streamlining legal processes and improving accuracy in the legal industry. Generative AI creates new content by learning patterns from existing data, making it a powerful tool for many industries, including law. Some key applications in the legal field include contract drafting. Genai can automatically generate standard contracts or legal documents based on user inputs, saving time and ensuring consistency. Legal research. It can help generate summaries of legal cases, statutes, and precedents, providing lawyers with quick insights for their research. Automated legal responses. Genai can assist in creating responses to client inquiries or generating legal arguments based on case facts. Document review. It can create models to review and identify key clauses, potential risks, or inconsistencies in legal documents, speeding up the review process. Intellectual property, IP protection. Genai can assist in generating unique ideas or content for patent applications and checking for potential plagiarism or copyright issues. Generative AI in law enhances efficiency, reduces manual effort, and aids in creating high-quality legal content quickly. Want to dive deeper into generative AI? You can explore Generative AI for All, a dedicated course where we'll take a closer look at how this technology works and how it can be used in various sectors. The future of AI is brimming with possibilities. As technology advances, we'll see systems that are not just smarter, but also more capable of understanding and adapting to new situations with minimal intervention. These autonomous AI solutions will redefine industries and how we interact with technology. At the same time, responsible AI development will take center stage. Ethical considerations and robust governance frameworks will become essential to ensure that AI benefits everyone equitably and avoids potential misuse. We can also expect AI to merge seamlessly with other cutting-edge technologies like quantum computing and blockchain, unlocking new opportunities we can only begin to imagine today. The potential for innovation is limitless, making AI one of the most transformative forces of our time. AI is transforming industries across the globe, bringing innovation and efficiency like never before. Let's see few use cases in various sectors. In healthcare, AI plays a vital role in disease diagnosis, drug discovery, personalized treatment plans, and even analyzing medical images to assist doctors with faster and more accurate decisions. In finance, it's a game changer for fraud detection, algorithmic trading, risk assessment, and providing personalized financial advice tailored to individual needs. In education, AI-powered tools are revolutionizing learning by offering personalized learning experiences, intelligent tutoring, and automating administrative tasks for educators. In entertainment, AI creates realistic game characters, generates tailored movie and music recommendations, and even produces art, blending creativity with technology. Finally, in self-driving technology, AI powers autonomous vehicles and drones, paving the way for safer and more efficient transportation and logistics systems. AI is reshaping the world as we know it, making these innovations possible across every sector. This concludes our module on the basics of artificial intelligence. We've covered key concepts and applications to build a foundation for the upcoming modules. Next, we'll dive deeper into AI's role in legal practices, exploring advanced tools and real-world applications. This foundational knowledge will help you better understand how AI is transforming the legal landscape. Let's move on.